Hello everybody, welcome to my YouTube channel Easy Mathematics. In this video, we are going to discuss the behavior of the P series. So first of all, what is P series and how it looks like, that we should know. So P series means it is the form summation of 1 by n to the power of P, where n varies from 1 to infinity and P may be anything. It lies in any real value, that is P value may be any real number. So the series is actually, it is 1 by 1 to the power P plus 1 by 2 to the power P plus 1 by 3 to the power P. In this way, if it will proceed, then this one is called the P series. So remember, P should lies in between the real number set. That means any real number may be P value for we can consider. So this P series, we can say it is convergent for P greater than 1 and it diverges for P less than equals to 1. So how we can say so? For that, we should at first analyze that P values are what and where we analyze for this P value. First of all, the P value we know it is the value which lies in the real number set. So P can take any real number. So that according to that, we can say P value might be negative, positive or 0. So if P value is negative, that means we can write P is less than 0. If P is 0, then P is equals to 0 we should write, and if it is positive, then P greater than 0. So we analyze when P value is 0, then what happened? When P value is less than 0, then what happened? And when P value is greater than 0, then what happened? P value 0, when it is greater than 0, that time again we create three situations. One is if P value is exactly 1. Another is P is less than 1 and P is greater than 1. So for all those P values we analyze the P series and its behavior. So let us discuss it one by one. First of all, if P is equals to 0, the given entire series for wherever we will have the P, instead of that P we should substitute 0. So in this series, if P is equals to 0 we substitute, then we will find out 1 to the power 0 means 1, so it is 1. Then 2 to the power 0 is again 1, so it is 1. So entirely all the terms becomes 1. And this 1 added infinity number of times. So the total summation for this 1 should be infinity. So that we can say when P is equals to 0, the P series is a divergent one. Now when P is less than 0, P less than 0 means let P value is minus R. So where R should be greater than 0. So that if we will substitute P for minus R, then it becomes n to the power R, because 1 by n to the power minus R is n to the power R. Now the series becomes 1 to the power R plus 2 to the power R plus 3 to the power R. In this way it is infinity. Hence lastly we will find out infinity to the power R. So which is definitely leads us to the value infinity. So again when P is less than 0, then we will find out the P series is divergent. Now if P is equals to exactly 1, if P is equals to exactly 1, then what happens? We substitute P for 1, so that we will find out the series as 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, in this way up to infinity, which is an infinite harmonic series. And we know if we want to take its summation, then as n tends to infinity, the summation is 1 upon d log of 2a plus 2n minus 1 into d divided by 2a minus d, where a should be 1 and d should be 1. So if we substitute all, then we will find out it is limit n tends to infinity log 2n plus 1. When n tends to infinity, so log infinity is finally infinity. So it is again divergent. So that we will find out when P is equals to 0 or less than 0, then the entire P series is divergent. Not only that, when it is the positive P value we consider and when it is exactly 1, then also it is divergent. Next we discuss if P value is greater than 0 and it is not equals to 1, then what happens? So have a look. If P is greater than 0 and it is not equals to 1, then here 1 to the power P or 2 to the power P, no one these terms are negative. So that as P greater than 0, the given series is a positive term series we can say, and it is monotonically decreasing as in value increases. here the nth term is 1 by n to the power p. So which can be expressed as the functional form. So its functional form we can say fx is equals to 1 by x to the power p. That I have explained while we express the geometrical form of APGP-HP. You can consult that video of mine where the APGP-HP express in the geometrical point of view. Now, so here this nth term can be expressed in this functional way, and this one is the graph of this one as it is the harmonic series. This one is a harmonic series with order p. So this one is also the exponential series which we can express in this functional form. And if we take the integration of this function y is equals to fx is this function. So if we take the integration from 1 to infinity, then we will find out the desired value of the given series. So now being a harmonic series of order p, so that this one we can take using the integral form of this one. So that summation is approximately equal to the integration from 1 to infinity 1 by x to the power p dx. So which is an improper integral. So we know how to solve the improper integral. So for improper integral we consider a m value where m tends to infinity, definitely m is greater than 0 and p not equals to 1. So for that the integration of this one we will find out x to the power of minus p plus 1, that is I have written here 1 minus p divided by 1 minus p, and the limiting value is 1 to m. If we substitute the corresponding limit when p value is greater than 1. So p value is greater than 1 means this part is negative. P value is greater than 1 means this part is negative, and power of x is also negative. Power of x negative means 1 upon x to the power positive power. Power of x is negative, that means x to the power of, we will find out if p value is greater than 1, then we will find out it is something negative, suppose it is r. So that one means we can write it is 1 by x to the power r. When r tends to infinity, because here m tends to infinity is given, so that tends to 0 definitely. So that for p greater than 1, we will find out this limiting value is 1 divided by 1 minus p. And when p is less than 1, that time x, its power is positive. So as it is going towards infinity, so that value going towards infinity again, so that finally we will get it is as infinity. So by applying the integral test, this one is the integral test we can say. So this integral test if we apply, then we can say that we conclude that the given p series is convergent when p value is greater than 1. And it is divergent when p value is less than 1. So that we will find out that the p series is convergent when p value is greater than 1 and it is divergent otherwise. So that if p is less than equals to 1, then it is divergent, and if p is greater than 1, then it is convergent. So that is the p series and its proof we have done here. Just remember the p series I have proved it by the integral, that means by taking the integration of the function in this format. You will find out the proof of this p series in different ways. So while we do the comparison test, that time there is another method to prove that the p series is convergent or divergent. So that dimension also we will discuss while we consider or while we prepare the video for the comparison test. So right now this is one of the method to prove that the p series is convergent for p greater than 1 and divergent for p less than is equals to 1. So that's all for this video. I hope you like this video, because p series its proof is very important for the entire sequence series. So just go through the lecture again and again if you can't understand, so that you can get it better, because it is really an important series. So have a nice day and thank you all.